Hi everyone, welcome to Python Osmosis, episode 37, the screencast that instantiates nothing but class. I'm Ryan Shane, and this episode we'll be talking about moron classes. So let's get right back in and continue where we left off with classes. I'm going to create a new class called car that has a little bit more detail, makes more sense as to why we would need a class. Okay, so again with our docstring, a car class. So far, cars have 4 wheels, and init underscore underscore self, always pass self, make, model, we're expecting 2 different things in the constructor, and tie those to the instance, self.make equals whatever we passed in the constructor as make, self.model is whatever we passed in as model, and then we'll do a couple other things. Self.trunk equals, this is going to be an empty list, all cars have trunks. Self.mileage equals 0, odometer start at 0. Let's create a definition. Load trunk. Again, tie self to that so that it's instance specific. So you can load up the trunk with whatever stuff you pass into this, and then self dot load trunk dot trunk dot append stuff, and drive self miles self dot mileage plus equals 2 miles, and then def picnic self dot load trunk basket. Okay, so a few things of note here. Okay, wheels is 4. So I created an empty trunk. So when you instantiate the class, you will have a trunk on your instance of a car, and it's going to start out as empty. And you'll have mileage, you'll have an odometer, and that's going to start out at 0. You have this class method load trunk, so you can send anything to the trunk, and it's going to append onto this empty list here, whatever you pass into it. And note here, self.trunk. I didn't just call trunk, I called self.trunk. That's how I reach in and modify the instance attribute trunk. Same thing with miles. I modify mileage by saying self.mileage. And I can also call a method from a method. So picnic is a method that is going to load up my trunk with a basket. So I call self.loadTrunk basket. So let's make an instance of this. Ryan car equals car, and remember that our constructor requires that we send through a make and model. And so now we've got Ryan car dot, and we see we've got all of the methods that we just created. So let's look at the mileage. It's 0. Let's see, trunk, what's in our trunk? Nothing. Car dot trunk dot append, let's put a shovel in the trunk, no reason. Ryan underscore car dot trunk, you see a shovel. Ryan underscore car dot, now let's go on a picnic. Now that doesn't take any arguments, you just call it like that. Ryan underscore car dot trunk, and you see we have a shovel and a basket in the trunk. Let's drive. Ryan underscore car dot drive. Drive took a number of miles, so let's say 100. Ryan underscore car dot mileage 100. Car dot drive 20. Ryan underscore car dot mileage. So I could create a new car, Bob's car, and basically it's a way of separating everything out and having these cool functions that you can run on each of these objects separately. Okay, next we're going to talk a little bit about inheritance. So inheritance is something that is almost always there in object-oriented programming languages. So let's create a new class called clown car. And I made all those cool little functions and attributes of car, and I don't want to have to do that all over again because a clown car is just like a car. So I'm going to inherit from car. And notice when we created classes before, we didn't put anything after our camel case class name. We just created the class. Now we're actually we have a parenthetical thing, just kind of like what you do in a definition, but in here is what you inherit from. So we're inheriting from car. So it's going to start out, it's sort of like a template. Clown car is going to inherit from car, except let's say a clown car has 3 wheels. Wheels equals 3. So the best way to think about this is what this is called is overriding. I overrode what was in the base class. The base class had wheels 4. Cars have 4 wheels. A clown car in this case has 3 wheels. And then I could also have a class attribute of clowns equals 100. So every clown car in this case starts out with 100 clowns in it. So there is my class, and now let's create an instance of this. Clowny equals clown car. Now remember, the base class has underscore underscore init underscore underscore, so I still have to instantiate this the same way. Toyota Prius. So now Clowny dot tab, I have everything that I had in the base class, even though all I did was overrode the number of wheels and added an attribute called clowns. It's pretty much the same thing as a car, except for it's got extra stuff. So yep, there's 100 clowns. I can clowny.clowns plus equal 10 clowny.clowns. Now there's 110 clowns in my car. So that's inheritance. Very useful. Anything can be overridden, and the way that Python looks for attributes is it first looks in the most contained class and then kind of works outwards. So if you had a class that inherits from a class that inherits from a class, it will start in the innermost class looking for an attribute, and then it will continue on toward the outermost class. This is both for data attributes and for instance methods. So let's talk about isInstance. There's a couple of methods that are built in for sort of testing to see if an object is a particular type. So we just created this object called Clowny, so let's do isInstance, and then let's say Clowny, and then car. Now we know it's a clown car, but is it also a car? This will return true. Quick way of testing for sort of derivation. There's another method, another built-in called isSubclass. So if I wanted to determine if clown car is a subclass of car, I could do that with isSubclass. Is clown car a subclass of car? Does it inherit from car? Yeah, it does, and that's true. So let's say I wanted to create something that inherited from more than one class. There's something in Python called multiple inheritance. So let's see. I could create, let's do class clown truck, and that's going to inherit from car and clown car. Now in clown car we know that we have clowns as an attribute that was added on, and we also overrode the number of wheels, if you remember. So this is particularly interesting. Now on clown truck we want to have a hitch, and that hitch is going to be whatever, a class 1 hitch. So let's Binky equals clown truck, and that's a Ford F-150. Alright, so notice we have our hitch. We also have clowns that we got from clown car, and we've got sort of everything that came along with just a normal car. But now the question is, what about wheels? Wheels in car was 4, and wheels in clown car was 3. So the way that Python with the old style classes, in other words, not Python 3 and not forcing classes to new style, the way it's going to look through is it's going to look in this, then it's going to look in this. So clown truck didn't override wheels, so it looks in clown truck. So nope, didn't find wheels there. Then it's going to look in car. Did it find wheels in car? And it did. So therefore Binky.wheels was 4. Okay, now let's talk a little bit about private variables. So in Python you can create sort of semi-private variables with this munging method. So let's actually create clown truck again. Clown truck, and that's going to inherit from car, clown car, and again hitch equals class 1. But now I want to make something that's totally private. Serial, the serial number of the car. What I did was I prepended it with underscore underscore equals whatever, 1, 2, 3, 4, 5. So now when I create a foo equals clown truck Ford F-150, if I try to access foo dot underscore underscore serial, I get this back. Clown truck instance has no attribute underscore underscore serial. Well, we just created one. We saw that. What Python does is data munging. So if I do foo dot tab, you see it created this underscore clown truck. It basically takes the attribute that you've created and it prepends underscore the name of the class before that name. So it's just sort of obfuscating. It's not actually making it private. If I wanted to change the serial, I could actually say foo dot underscore clown truck serial equals 54321, and that would actually work. Foo dot underscore clown truck underscore underscore serial. So it's just a way of discouraging you from tweaking around with the variables that are in there, just by prepending underscore underscore. let's talk a little bit about creating a simple base class. So I guess in Pascal there's something called a record, and in C there's something called a struct. Classes can be used just as an empty container for sort of bundling attributes together. So let's take a look. We're going to take create a class called employee, and this class is going to do absolutely nothing. We're just going to say pass. So now we have this class. It doesn't have a constructor, it doesn't have any attributes, it doesn't do anything. But we're going to use that to bundle attributes together. So John equals, and we're going to instantiate the employee class. And now I can say John.name equals John Doe. John.department equals computer lab. John.salary equals 1,000. So now it was just a convenient way to create a container without having to do too much work. So you might find that useful, or a replacement for those C structures or Pascal records that you're used to if you're coming from those types of languages. Another thing that we touched on was exceptions before, and exceptions are they're classes. So let's look at an example here. Class B. Okay, and we're just going to have that pass. Class C, and then we're going to inherit from C, we're going to inherit B. That's still just going to pass. Class D is going to inherit from C. Alright? Whoops. Forgot I wasn't out of the class. Alright, let's redo C there. Class C inherits from B. Class D inherits from C. So now we have those three classes, B, C, and D. B is the base class, and C inherits from B, and D inherits from C. Now, the reason that I'm showing you this is so that you can understand how Python works with raising exceptions with regards to classes that inherit from other classes. So what I want to do is now loop through each of those and raise the exceptions. So for C in, we'll just have a list here, B, C, D, try, raise C, so whatever R, as we iterate through here, raise B, then raise C, then raise D, and then we're going to try and catch the exceptions, except D, print D, except C, print C, except B, print B. Okay, now what's important about this is just to note that, so B was the base class, C inherited from B, D inherited from C. So as we loop through, B, it's going to raise B, and is B an exception that is D? No, it's not. Is B an exception that is C? No. Is B an exception that is B? Yes. Is C an exception? Well, actually, let's just take a look at this. So printed out was B, C, D. Now if these were reversed, if first I had except B, print B, and then I had C and D, we would have had B, B, B print here, because since an exception is a class here, the first one, B, D is an instance of B. It inherits from C, which inherits from B. So you have to be careful about how you're catching these exceptions and how they're inherited, because you may end up catching the wrong thing. That's all for now. This screencast is directly inspired by the Python tutorial by Guido van Rossum at python.org.